Hello everyone. My name is Somaya. I'm a lecturer at Technological University Dublin. I'm going to explain up chirping and down chirping as a spread spectrum modulation scheme for LoRaWAN. This type of modulation is applicable for Internet of Things, so it is useful to know some basics of that and how we can use that for encoding our binary data. So I'm looking at up chirping and down chirping. For LoRaWAN IoT applications. Okay, so we have two types of sinusoid pulses. We call one of them for up chirping and another one for down chirping. So the one that I'm going to draw on the left side, I'm going to have the up chirping. When we are looking at up chirping, we are looking at the moving from low frequency to high frequency with fixed amplitude. So these dashed lines are for fixed amplitude on the positive side and fixed amplitude the negative side. Now, so here on this side, I'm going to draw a sinusoid that has a very low frequency and gradually moves to a sinusoid that has same amplitude but higher frequency. And on this side, I'm going to draw a sinusoid that starts with very high frequency and then gradually moves to a sinusoid with same amplitude with a very low frequency. So if you imagine that that would be my center, and I'm starting from very low, wide, loose wave, and I'm increasing the frequency, meaning that I'm oscillating more often. So as you can see, at this stage here, I have very low frequency, and here I have very high frequency. So here is high frequency. Opposite story happens here. I'm starting from high frequency and moving gradually. So my high frequency is happening here, and I'm gradually reducing the frequency. So that means that my sinusoid is oscillating less often. So this would be time domain. Now, if I want to draw two diagrams, so again on the left side I am going to draw how linear is the relationship of my high frequency and low frequency, how that changes occurring based on frequency. So I will have this diagram here. I'm going to show that with my, this is my F low and that is my F high. So again, F low and F high. So on this side I'm going to have my up chirping, and here I'm having my down chirping. Now what's happening here? Now in up chirping, if I want to refer to what I explained here, I'm starting from low frequency and I'm moving toward the high frequency. So if I want to draw a line here explaining that, that will look like something bit, let's say, from here to here is going to have straight line, because the derivative of that should be a fixed number. So that is representing my up chirping pulse. Now if I want to do that for down chirping, I'm trying to have identical shape. Here I'm moving from my high frequency to low frequency. Again, it should be a very straight line, because derivative of that line should be a constant number. That will be my pulse for down chirping. I'm going to have one example converting some bits to that. Let's say my binary data bit is, I want it to be different from the one that I explained in the class. So let's say 0, 1, 1, 0, 1, 0, 0, 1. Now let's say this is my low frequency and that is my high frequency. Now I decide that I want to send up chirping for my ones and down chirping for my zeros. So let's write that somewhere to remember. So up chirping for 1 and down chirping for 0. So I have 0. So I'm looking at down chirping. I'm looking at this guy here, and I'm looking at this guy here. So I'm going to have a straight line from my high frequency to my low frequency. Now I'm looking at digital 1. Digital 1, up chirping. Up chirping, I'm looking at this guy here and this guy here. So I'm moving from low frequency to high frequency. Again, I have 1. I don't continue that. Remember, it has to have constant amplitude. So it's going to have another chirp pulse here. I have 0, meaning that I am going to have one of these guys here. I have 1 up chirping, 0 down chirping, 0 another down chirping. Remember, I'm not coming down here, I'm not continuing it because again constant amplitude. So I'm going up. Digital 1 is going to have. Now let's look at it again. What is this one? This is down chirping. I'm writing DC, down chirping. What is this one? Up chirping, UC, UC, DC, UC, DC, DC, UC. That's how we can encode and convert our binary data using down chirping and up chirping. This modulation scheme is called chip spread spectrum, and that helps LoRAWAN technology to spread the spectrum in a very wide range, and that provides very low power energy signal that can be sent within very nice long range that is associated with LoRaWAN. I hope everyone understand. If you have any question, feel free to ask me during the lecture on Thursday. Thank you. Bye-bye.